So I have just grabbed one of the groups. In this case, it is International 5. In the top right-hand corner, I've tried to magnify what I'm looking at. Hopefully that'll help you a bit. But as you can see here, this is the folder I'm working in, Analytical Chemistry, International 5. And of course, there are different programs you can use once you've logged in. So the one that you have tried, let's just see, I should have a real time. There we go. So this is the software you actually use during the course, where you set up the system or set up the method. Actually, we set up the method and then you did the quick batch. Let's see if it wakes up. It does. So in the quick batch, you could select what samples you wanted to run. So that's one part of the software that's available. When you're doing the data treatment, what you want to do is you want to open up post-run analysis if it isn't open already. And the way you do that, let's just see. Actually, can't remember. I think if you click data analysis, so you up here you click real-time batch. Then you select this one, data analysis, and that'll open up the program here, and that is called post-run analysis system. So let's fire that up. That's what I have open here, and I've selected the folder. Let's say you're a different group. If you're lucky, your group will be in the drop-down menu. If not, you just click on this lovely select project folder, and then you select the folder where your data is stored. So we're just going to have a look at some data from International 1. Let's see, do we have something interesting? I think this must be their standards. So let's try and open up a standard and see what we get from that. Here we go. Now, if you look at the chromatogram you're getting here, right away we can see at least two quite obvious peaks. If I recall right, the first one will be the limonene, and the second one will be your internal standard. And actually, I don't know if you can see it, but we have an even bigger peak. I should actually be able, let's see if I can zoom out enough for us to see. Play settings, and let's zoom out even more. Okay, we actually can't zoom out that far. In some cases, what you will see is your initial peak, which is from the methanol. Of course, because you're using that as your solvent, as your extraction media, you're going to have way more of that than anything else in your samples. If that starts to mess it up for you, you basically just have up here, you can zoom in. So for instance, if I'm interested in this peak here, I can just zoom in on that peak and you can see the bottom image actually updates so I can see it more clearly. I quite often use the display settings because then you can actually fix it. So if it's something that often gives you trouble, actually this might be it. $16. Okay, so we have our peaks here. Now what you'll see here, the red markings, that's actually where the software has detected that there is a peak. So in this case, you can see it detects the first peak, then it detects some other smaller peaks here, and the big one here, and then you have a bunch of other ones. This can partly be because of noise, and you can combat that by, for instance, subtracting a blank sample. So let's see, did they run a blank for us? If they did, they didn't give it a name that I can recognize as a blank. You know, we're just going to check one of the other groups. What do we say to international? We'll take this one perhaps. Take a standard 100 again. So this is the group 4 of the Danish team. Let's see. Again, we have some peaks here. Have a peak there. We have a small peak. Actually, that's probably due to scaling, because that's actually quite a large peak. So that should be fine. Okay, anyways, what you can then decide to do is you can subtract a background. So basically, if you've run a blank sample, you can take that signal and you just subtract it from all of your data. The way you do that is up here at the top. We can select background data file, and we're in DK4, and unfortunately their file names are a bit difficult to deal with, so let's just see. We want, one of their blanks would be 620. This should be a blank, if I read their data right. So let's try and open that and see what happens. That's a problem for Team 4. We'll have to discuss that, Team 4, unless I picked something wrong. I might have done. What you can see is we start to get negative peaks. So basically, this is probably the methanol peak. For the GC results, in general, you don't have to do this. They tend to be quite nice and clean, even if you don't do this. I'm just showing you how to do it. But we've selected a background file. If you want to use the same blank for all of your samples, instead of having to open it every time, over here just to the left, you can pin the background. And what that means is now if I open a different data file, I don't want to save any data, don't want to mess it up for them, you can see that it automatically subtracts the same blank sample. So that makes it a bit easier for you to actually deal with this. Now, for the export of data, that's actually what you're interested in. At the moment, and for quite a while actually, GC software has been acting up a bit, but once you are happy with how your peaks have been detected, so that's something you can actually start to mess around with some, where is it, manual integration bar. So you can actually, for instance, this one, I think that overshoots by quite a bit. So I could take that and draw it back in. And in this case, it might be a good idea to zoom in on the peak, and we can say, you know what, I would like you to calculate from here to about here, seems fine, for instance. And what you then do to get the data out, file, and then you go to data reports, and I believe it is preview. We'll now try it. Second. And you can actually see we have here our two retention times, we have our areas, we have our heights. The concentrations you can't trust. That's from a previous calibration setup, so you can't use those concentrations. You can use your areas and your heights. And you can then print it as a PDF or just type these into Excel or whatever. But that's basically how you get these things out. And let's go back. So you can also, sorry, it's a bit slow. Is it? So I can do a PDF output and get it like that. I believe if we export the data as an ASCII file, it won't work properly. We'll just try it. Yeah, so for some reason you can't export the areas, which is what you're interested in, as far as I can see. Let's just try and copy it to a clipboard. And when it's done with that, let's fire up Notepad and see what data we actually, oh, we actually get it here. You would have to check if those numbers match, because then you can do it like that. That's actually quite a bit nicer. So once you have detected your peaks, it actually looks like you can then export as an ASCII file. So that's just a pure text file that gives you all of your data. I'm not sure if it gives you the chromatogram. It doesn't look like it, but we can probably ask it to do that. So we'll just try again. Where is it? File, export data, ASCII. We can ask to get our chromatogram as well. One of the reasons you might want to do that, I'll show you now. Let it export. Fire up Notepad again. And what you actually see. So at the top, we have the same information we had before with our peak tables and all of this. And then we have our chromatogram. So this is actually your raw data. So if you were to take all of these values, that's quite a bit, copy them into Excel and do a and make a plot using those data, you would get how do I get rid of that? You would get this chromatogram. So that's actually all of your raw data that you can use if you want to make a plot or if you want to do data treatment in a different software.